Density is a type of measurement that is very important for us to understand and know. And you may ask yourself, why? Well, we have some reasons here. One, did you know that density is the reason that all boats float? Because the inside of a boat has more air and less water, obviously, than outside of it, it retains the ability to keep floating. Without that air inside of the hull of a boat, it sinks. Believe it or not, planes have a lot to do with density. The reason why in a plane you have a distribution of seats from the front to back is if you didn't have that there, and let's say you packed the front of the plane with a lot of people and kept the back pretty much empty, when the plane started to get lower on fuel, the plane's nose would actually tip down because the front would be more dense, and the plane would then drift in that direction. In medicine, we have a lot of density related things. This first picture here is of a x-ray, and we see x-rays because bones in our body are much more dense than the muscles around our body. And if we didn't know that and we didn't understand that, we wouldn't understand the picture that we're looking at. And there are lots of other related things in medicine to density. If you've heard of somebody having high blood pressure, that would mean that there is cholesterol in their bloodstream that is making it much more dense, and it's harder for your body to pump that around. You've heard of people getting CAT scans and MRIs, and what they're looking for are things that are more dense, and that tells a doctor that related to the tissue surrounding it that there is something wrong with that part of the body. So the definition of density is the ratio of the mass of an object to its volume. In other words, it's how much stuff is in a given area. So what I mean by a given area, here you can see two squares that are exactly the same size, and in those squares are Mr. D's. You can see in square 1 there are 4 Mr. D's in that given area. In the second square there's only 1. So according to what we see in this picture, the first square actually has more Mr. D's per given area and therefore is more dense. Here we have another example. In this picture we have a given area with 4 Mr. D's in it, and then another given area with only 1 Mr. D in it. If you were to actually measure the volume of those objects though, you would note that the smaller square is actually 1/4 of the first square, the bigger square. That means that if you were to take the first square, divide it into 4 pieces, each of those 4 pieces would have 1 Mr. D. The other square, the smaller one, has 1 Mr. D. That means that both of these squares, although different in volume and different in mass, are actually the same in density because they have the same amount of Mr. D's per given unit. So let's look at this another way. Here we have that same big box with 5 Mr. D's in it, and that same small box with 1 Mr. D in it. We know from the last picture that box, the first box, can be divided into 4 squares that are the same size as the second smaller box. But because the first box has 1 more Mr. D in it, the ratio of Mr. D's in those boxes are not equal, and therefore the first box actually is more dense. Here is another way to look at it. In this picture you can see that there are different weights representing different types of metal. What you don't know is that all of these actually have the same mass. How is that possible that this magnesium weight can have the same mass as this weight here that says gold? Well, it's pretty simple. Their densities are much different. The gold is much more dense than the magnesium, which means it has more stuff in a given area than the magnesium does. So I wanted to show you with some household products what that kind of looked like. And I used some liquids. This one is Karo syrup, and you can see in the picture that the amount of liquid in that beaker is roughly 50 milliliters and its mass is 65 grams. Here we had water. Water was actually about 80 milliliters and was roughly 63 grams. So very close to the same, even though there was much more liquid in there. This one was coffee creamer. You can see that it's still about 64 or 65 grams, but the amount of liquid in there is closer to 70 milliliters. And here, this one is just regular vegetable oil, and this one again was roughly 80 milliliters, but it was still around that same amount in mass, which was about 64 grams. The point with these liquids is that you can have liquids that have a lot less volume but have the same amount of mass. The Karo syrup was roughly 50 milliliters in volume, but still had roughly the same amount of mass as the other three liquids. So the last thing that I wanted to show you were some solids that I had laying around the kitchen, and these were two easy things to find. I wanted you to be able to see with just an eye test that these two objects were actually different in size, and I think you can see that pretty well. We have a wooden spoon and a metal spoon here. When I put the wooden spoon on the scale, you can see that it was only 42 grams. So compare that to the metal spoon, which was obviously smaller in size. That was actually much larger with 80 grams. So even though the wooden spoon was larger in volume, the metal spoon had a much higher mass, which tells you that the density of that object was much greater than the wooden spoon. So our key takeaways from this video: first, density is a huge part of our lives. I put the cityscape in the background with all of its smog just to show you one other way. We talk about smog in the air as parts per million. You may have heard that term before, and that is another way of describing density. Another key takeaway is the definition, and we're putting this in our super simple terms. Density is how much stuff is in a given area. We also talked quite a bit about how density is tied to mass and volume, and that goes with this last one down here below, that size does not determine density. You saw with that wooden spoon, even though it was much larger in volume, its mass was greater. So that's another great example of showing you that size doesn't determine an object's density.